Today we are doing 2.5, solving compound inequalities. So a compound inequality is an inequality that's made up of two inequalities all together. So it's going to be joined either by the word and, or it's going to be joined by the word or. And may not always be there. It may be smushed together as one long compound inequality. And I'll show you what that looks like here in just a second. So for compound inequalities, it's always assumed to be an and statement unless it specifically says or. Okay, so for and statements, you're always going to combine your two answers into one long compound answer. For or statements, you're going to make sure and just keep it as two separate ones. Okay, if we have an and graph, we're looking for where the two graphs overlap. We want to know where does it work for both this inequality and the other inequality. Whereas an or, we just care about where it works for at least one of the places. So it either works for one or it works for the other. It can work for both, but it has to just be at least working with one of them. Okay, so we're going to write this sentence as an inequality, and then we're going to graph it. It says a number u is less than 7. And then we're still talking about u. It says u is also greater than 3. And we've got the word and in the middle. So if we're going to be writing an and inequality, we're going to put our smallest number on the left, our biggest number on our right, and our variable in the middle. Then we're going to put the inequality that corresponds to each of those sections. So between the u and the 7, the inequality was opening towards the 7. So between the u and the 7, I'm going to have the inequality opening towards the 7. Between the u and the 3, the inequality was opening towards the u. So between the u and the 3, I'm going to keep the inequality opening towards the u. This would be our first compound inequality. Okay, that is an and inequality. So we want to know where a graph shows that it works for both inequalities at the same time. So let's graph them each individually. So first I'm going to graph the u is less than 7. All right, so let's see, 2, 3, 4, 5, 6, 7, 8, 9. All right, so u is less than 7 would be an open circle on 7, and our arrow is going to go to the right because we want everything less than 7. Okay. For u is greater than 3, we'd have an open circle on 3, and our arrow would be going to the right because we want everything greater than it. If we're talking about an and statement, it has to be a part of the graph where both inequalities show that as an answer. So the only section on this graph where it works for both of them is in between those two circles. So that's what we actually want to have for our final answer. Okay, so we're going to shade this area in nice and dark to show that this is our final solution set. And then we actually have to erase anything on this side over here. Okay, so our final answer is just the part in between those two equations. Okay. All right, so let's take a look now at the next one. So it says d is less than -2. Or the same thing, we're talking about d still, d is greater than or equal to 2. Because it's an or statement, we can't squish it together. So we leave it as two completely separate inequalities joined by the word or, and that's our final compound inequality. To graph it, we just graph them as two individual graphs. So let's see, we've got -3, -2, -1, 0, 1, 2, 3. For our first inequality, it says d is less than -2. So that would be an open circle arrow going to the left. For our second one, it is d is greater than or equal to +2. So that would be a closed circle arrow going to the right. And because we're talking about an or statement, we want to know where does it work for one or the other. It works for this inequality over here. It works for this inequality over here. So that's our final answer. In other words, every single number over here is a solution. The only numbers that would not be a solution to this inequality would be in this middle section here that doesn't have either of the inequality line drawn over it. Okay. Number 3, a number s is no less than -2 and it's fewer than 4.2. So s is no less than -2.4, which means it's actually going to be greater than or equal to -2.4. And then we're still talking about s. It says s is fewer than 4.2, so that would be s is less than 4.2. Okay. Because it is an and inequality, we do need to smush it together. So we're going to put negative 2.4, our smallest number on the left. We're going to put 4.2, our biggest number on the right, and our variable goes in the middle. So then we go back and look at our inequality sign. So we can see that between the S and the negative 2.4, it was opening towards the S. So I'm going to keep it opening towards the S. Between the S and the 4.2, it was opening towards the 4.2. So I'm going to keep it opening towards the 4.2. So this would be the final way to write my compound inequality. When we're thinking about the graph, though, we're going to come back to our original one. So we're going to graph this one right here. And when we're doing this, you can choose your scale that you would like to use when you're doing your graph. I'm okay with you just using a negative 2.4 over here and a positive 4.2 over here, showing that it's a closed circle on the negative 2.4 and going greater than would be this direction. And then when its S is less than 4.2, that would be an open circle and the arrow would be going to the left. Once again, we're looking at an and. If we're talking about an and inequality, we want to know where does it work for both inequalities at the same time. The only section it works for both of them is this middle section in here. So ands are going to be that overlap region. Where does it work for both parts of your inequality? And then we want to go back and erase anything on the sides where it wasn't an overlap. So we're going to erase this section here, and we're going to erase this section over here. Okay, so let's look at another one. So it says a number C is more than negative 4, or at most negative 6.5. So we've got C, and it says C is more than negative 4, so that would be greater than negative 4. It says, or C could also be at most. At most would mean it'd have to be less than or equal to your negative 6.5. Okay, this is an or, so we don't have to worry about squishing it together. We can set up our number line. So we've got negative 7, negative 6, negative 5, negative 4, negative 3, negative 2 will be the scale that I will choose. C is less than or equal to negative 6.5. That would be halfway between. Closed circle, arrow going to the left. And then C is greater than negative 4 would be an open circle, arrow going to the right. It's an or, so we only care about one solution section, so we don't have to worry about an overlap region. There's nothing that we need to erase. We're only caring about where it works for at least one of our inequalities. All right, we'll do a couple more. So this one now is one we need to solve. So it gives us the inequality, and we actually need to solve it. So to do this, we're actually going to treat it like two separate problems. So I'm going to underline one problem in pink, and I'm going to underline the other problem in green for you. So let's look at our pink one first. So I'm just going to write what I have underlined in pink. 4 is less than x minus 3. And then what I have in my green is going to be x minus 3 is less than or equal to 7. So by setting it up as two completely separate problems, it makes it a lot more basic to solve it. There's less going on. So for this one, I'm going to start by adding a 3 to both sides. I have 7 is less than x. And then on my second equation that I've written, I'm going to add the 3 to both sides, and I get x is less than or equal to 10. Because it was smushed together in the original one, we know it is going to be an and statement. So our graph needs to show where it overlaps for both of them. So 7 is less than x is the same thing as x is greater than 7. So I've got a 6, 7, 8, 9, 10, 11. So x is greater than 7 would be an open circle. Arrow goes to the right. And then we have x is less than or equal to 10, which would be a closed circle. Arrow going to the left. We're looking for and. We want to know where they overlap. So because we want to know where they overlap, what we care about is where it worked for both of them. This section in the middle is what we care about. This would be our final solution set, which means we do want to go back and erase anything on either end. So that would give us our final answer. When we're thinking about giving our final answer algebraically, we'd want to come back up to this line right here. and we're going to smush it together. So we put the smallest number on the left, the biggest number on the right, our variable goes in the middle, and then we look at our signs. Between the x and the 7, it was opening towards the x, and between the x and the 10, it was opening towards the 10. So this would be algebraically how we would show our final answer, and our graph would show visually our final answer. All right, number 6. Oh, back up. One other thing. You can treat this as one big problem if you want. So I'm going to do that in a different color to show you that it would give you the exact same thing. So I'll pull up purple for this. So if I treated the original problem as one original problem, I could add a 3 here as long as I add a 3 to all 3 sections of the graph. So this would give me 7 is less than x, which is less than or equal to 10. It gives me the exact same answer all in one part instead of breaking it up into 2 separate parts. So you can choose which way you want to do it. Either one is great. Okay, so number 6, we can either break it apart into 2 separate problems, or we can treat it as one big problem. If we're going to treat it as 2 separate problems, it would be 15 is greater than or equal to negative 5g, and negative 5g is greater than or equal to negative 10. We know it's an and. We know we're looking for an overlap because it didn't have the word or. That's the only way it could be an or. The other way you could do it is by treating it as one big problem and dividing all 3 sections by your negative 5. Now here's where you got to make sure and pay attention. We divided by a negative number. When you divide by a negative number, don't forget you actually have to flip the direction of all of your inequality signs. Okay? So this one, treating it as one big problem, is really nice to get your answer algebraically. However, I kind of prefer breaking it up into 2 separate parts if I'm thinking about my graph, because it's going to be set up a little bit nicer for that graph. So if I were to show the same thing over here, I would end up with negative 3 is less than or equal to g, and divide by negative 5 over here. I get g is less than or equal to 2. This one here I want to flip so that I have it written with my g on the left-hand side. And then it becomes a little bit easier for me to see what I am actually going to be graphing. So g is greater than or equal to negative 3 would be a closed circle, arrow going to the right. G is less than or equal to 2 would be another closed circle, arrow going to the left. And again, we're looking for where does it overlap. The overlap, the and region where it works for both of them is in between. And then we want to make sure and get rid of anything on either side to show that we only want where it corresponded to both of them, and these were both closed circles. I apologize, it seems to have erased those for me. There we go. Okay. All right, let's do one more just to make sure that you've got it, and then we'll look at an open-ended type question. So in this one, it's an or, so we can just treat it like 2 separate problems. So we'll subtract the 4 on both sides. We'll divide both sides by negative 3 on this one. Don't forget to flip the direction of your inequality sign and join it by the word or. So we have z is less than negative 2 or z is greater than 9. So I've got negative 2's down here. 9 would be up here. Less than negative 2 would be an open circle, arrow to the left. Greater than 9 would be an open circle, arrow to the right. It's an or, so we care about where it works for one or the other. It doesn't have to have an overlap region, so there's nothing that I need to erase. All right, last thing to look at says to write an inequality represented by a graph with an open circle on negative 3. So we can visualize this. Open circle on negative 3 and a closed circle on 2. And the line is shaded between the 2 numbers. So if the line is shaded between the 2 each others, we know it's going to be an and, which means that this open circle had to have an arrow going this way and this closed circle had to have an arrow going that way. So we can write it with our smallest number on the left, biggest number on the right, the variable in the middle. We know that x is everything less than 2. And we know that x was going to be everything greater than negative 3. Greater than negative 3 of the mouth opening towards the x, so we're going to keep it opening towards the x. Don't forget our equal to sign on our 2 for our closed circle. All right, take a second, star the ones